Welcome to Pace Academy. Myself Shravani. Today we will start a new chapter called circles. Okay. So in the first, before introducing about the circles, we will discuss about some conic section part. Okay. So what is conic section part actually? That means here if you can take any cone. Okay. I am taking a cone like this. You can assume any ice cream cone or any birthday cap or anything, okay, like a conical shape. So if I cut this cone through this apex, okay, so this is apex, right? So through that apex, if you cut the cone like this, so what happened? So here if you cut the cone like this, right, through the axis, if you cut the cone, this part is removed or not? After cutting the cone through this axis, through this, not axis, apex, after cutting the cone we are getting, this part is removed, we are getting the cone is like this. So that means here what it forms? It forms a two lines. See, it forms a two lines. You can call these are pair of straight lines. What do you call it? Pair of straight lines. Okay, suppose you can take the same cone. So whenever you cut this cone parallel to the base, what happened here? Whenever you are cutting the cone parallel to the base, now what will you get the figure here? Which is circle, right? So if you cut the cone in slant, not parallel to the base but in slant without cutting the base, so that means like this, right? So if you cut the cone which is just some inclination without cutting the base, if you cut the cone like this, what it forms? It forms an ellipse. Here this figure is ellipse. Okay, and suppose if you cut the cone, like the cone is there, like, so with cutting of the base, some other part if you cut like this, so here I am taken like this. If you cut the cone, so in some inclination, with some inclination and through the base also, that time what happened here? This whole part is removed or not? Right? So this part is removed. So it forms a, after cutting a cone like this, okay, this part is removed. So it forms what? A parabola, right? So this is a parabola. Okay. So if you take two cones one upon another like this, so here this is one cone and here it is another cone. Okay, if you cut the cone not through the apex, some other way like this, so like this, if you cut it like this, so what it forms? Here it is like one parabola, here it is one like parabola. You can call it as hyperbola. So when you are cutting the cone in different positions, we are getting pair of straight lines, circles, ellipse, parabola and hyperbola, right? So that's why you are calling this all curves or all equations, you are calling it as conic section equations, right? Actually generally the general form of this conic section equation is second degree equation, that is ax square ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. Okay, so this is the general form of the all. Now we tell different types of conic section. figures, right? So this is the equation for all those figures, but based on some conditions you can tell whether this is a pair of straight line or it is a circle, parabola, ellipse or hyperbola. Okay, so here we have one determinant for this second degree equation. You can call it as a second degree equation or not? Yes. So here we have one determinant which is equals to, you can take A, B, C, H, G, F and H, G, F. Okay, this is the determinant of this second degree equation. So which is equals to what? ABC minus AF square minus H square C. You know how to do the determinants, right? Okay, minus H square C and plus HFG, and here plus G into HF minus GB minus G square B, BG square, right? So this is the determinant of this second degree equation. So what it is, if you write in simple form, ABC plus 2HFG minus AF square minus BG square minus CH square. Okay, so this is the value of delta here. Based on this delta and H values, ABC values, you can say this equation represent which figure. Okay, so if delta equals to 0 and H square minus AB is greater than 0, this is one condition for pair of straight lines. Already we learned, right? So if delta is 0 and H square minus AB is greater than or equals to 0, then this second degree equation represent pair of straight lines. And what about circle? Okay, so here the circle representation is delta is not equals to 0 and here A and B should be equal and not equals to 0, and here the H should also be equals to 0. This is the condition for this circle. So whenever this satisfy with this equation, then you can call it as this is the equation of this circle. Clear? Okay, we will see it later how the condition satisfies. First we will see what is meant by circle. So what is a circle? Circle is nothing but the collection of all the points in a plane. Circle means we can see different types of figures which is in the shape of circle, right? So bangle, generally we are talking about the bangle, and you can see many circular figures. So circle means it is nothing but the collection of points in a plane, the collection of all the points in a plane which are equidistant from a fixed point. Okay, which are equidistant from a fixed point. This figure is called circle. Okay, so the collection of all the points in a plane which are equidistant from a fixed point, you can call it as circle. So otherwise you can say that the locus of point, you can take x comma y. Okay, this is the locus of point which moves in a plane such that its distance from a fixed point, a locus of the point moving in a plane which is equidistant from a fixed point. So that is called what? Circle. Here the fixed distance is called what? Fixed distance is called radius of the circle. Okay, and the fixed point you are calling it as center of the circle, right? So the fixed point is center of the circle. So here you know already the circle divide the given plane into three regions. So one is inside of the circle, interior region, and on the region, and outside the region is called exterior region, right? So the circle divide the given plane into three regions. And one more thing here is when these two are So E is called what? So you can represent any circle like this. C is 0, O comma R. Here O is the center of the circle and R is the radius of the circle. If you represent any circle like this, C, O comma R, you can say that it is the center of the circle and it is the radius of the circle, right? Okay. Now here, this is a fixed distance, right? Always it is a fixed distance. Suppose you can take the center of this circle is at the origin. What it means? So whenever you are taken the coordinate axis, we are here talking about the coordinate axis, okay? So if you take the center of this circle as origin means 0 comma 0, right? And with a distance of r. Okay, so here the point is P, x comma y. This is the locus point I am taking. Okay, so if you take the center is 0, 0. Now what is the distance r here? It is always fixed, right? Constant. So what is the distance r? So from any point to the center origin, the distance is square root of x square plus y square or not? Yes. So square root of x square plus y square equals to r. What about r square here? X square plus y square, right? So here r equals to square root of x square plus y square. So from this x square plus y square equals to r square. This is the representation of the circle when the center of the given circle is origin, right? Suppose if the center is not origin, some other point, some h comma k you can take. H comma k is the center. And here P is the point, locus point, you can take x comma y, right? So this is the fixed distance and this P is rotating like this, right? Okay, right? So here, now what is the equation of this one? What is the distance between these two? R. So whenever 2 points are there, what is the distance formula here? H2 minus x1 whole square. So x minus h whole square. So x minus h whole square plus y minus k whole square, which is equals to what? R square or not? Right? So distance between these 2 points, x minus h whole square plus y minus k whole square equals to r square. This is called the standard form of this circle. What did this equation represent? The standard form of this circle. So this is okay. So here if you take h comma k is the center of the circle, then the equation becomes x minus h whole square plus y minus k whole square equals to r square. If you can take the center of the circle is 0, 0, then h0, k0, then the equation becomes x square plus y square equals to r square. Clear? So if you can see, wherever you can see that x minus h whole square plus y minus k whole square equals to r square, you can say this curve represents what? A circle. Clear? Okay.